Welcome to qnawire.
In this question, we have been given a very simple product and we need to find out these shapes of cations and anions. So the product is given as CH3, 4, and this is the cation part, while the SiF5, this is the anion part. Now we know this because in the representation of general ionic compounds, we write cation before anion. So we can say that the fraction that is written first is going to be our cation, right? While the fraction that is written after this, or we can say second, at a second place, is going to be our anion. That is why we can say that our cation is CH3, 4 and positive, while the anion is SiF5 negative of 1, right? Now to be able to find out the correct shapes using VSEPR theory, first of all we need to find out how many valence shell electrons are there on the central atom. So the central atom here is going to be the nitrogen atom, which is going to have a total of 5 valence shell electrons of itself, right? Now there are total of 4 methyl groups attached to the central atom nitrogen, which we can say that are connected through a carbon atom. Now each carbon atom is bonded by sharing 1 electron. So we can say that due to these 4 methyl groups, there would be total of 4 valence shell electrons on the central atom nitrogen. Now due to 1 unit of positive charge, we can say that we need to eliminate 1 electron. So now the total sum comes out to be 8, right? So we can say that the total number of valence shell electrons on the central atom nitrogen is going to be 8. So we can say that the valence electron pairs are going to be 4. Now what we can infer from this value is that the 4 bonded pairs of nitrogen central atom are going to be in a tetrahedral shape. So we can say that the correct structure of this particular species is going to be this nitrogen central atom, and then there are these 4 methyl groups attached to it, and then there would be a total of 1 unit of positive charge on this species. Now moving on to the anion part, so the total number of valence shell electrons in this part would be 4 due to the silicon atom, plus 5 electrons due to 5 fluorine atoms, as each of these fluorine is bonded through the sharing of only 1 electron, and that is why we can expect that 5 of fluorine atoms would be contributing a total of 5 electrons to the silicon atom. And now due to 1 unit of negative charge, we will have to add 1 more electron to the valence electrons of silicon. Now the total sum comes out as 8, and the total number of valence shell electron pairs would come out to be 5. Now since the total sum is going to be 5, we can say that the molecule is going to acquire a trigonal bipyramidal shape. So we can draw it like this. So there is this silicon central atom, and then the 5 fluorine atoms would be attached like this, and this whole molecule is going to exist having a 1 unit of negative charge. So these are the shapes of these two molecules. Now we can say that moving on to the next part of this question, which deals with the fluorine NMR, and this question says we need to explain why the fluorine NMR spectrum shows two different kinds of fluorine atmosphere, which means there are total of 2 kinds of fluorine atoms available in the given molecule. So now the reason behind this is that in the anion fraction only there are fluorine atoms, right? There is no fluorine atom in the cation part. So from anion we can say that there are 2 kinds of fluorine atoms, the ones that are axial positioned, and the other kind of fluorine atoms that are equatorially positioned. And because of these 2 kinds of fluorine atoms, we get 2 different kinds of fluorine atmosphere. So we can say that the 2 different kinds of fluorine atoms are axial and equatorial in the given product.